Hey people, so I mostly use 3.3 volts when using microcontrollers, specifically the mega ones. And my problem has been that the Arduinos usually run 5 volts, so I've usually made my own boards. Now I took a look and bought a few Arduino Nanos, and I figured out that they're pretty easy to convert to 3.3 volts, so that is what we're going to be doing now. So I looked up the spec sheets for it's a clone, the chip down here, which is what I thought would be the problem. It's the USB to serial converter, and apparently it can run 3.3 volts. You just have to make a little modification. So let's see if I can move the camera here without messing things up too badly. Yeah, great. Now pin 4 of this is the internal 3.3 volt reference kind of deal. Is connect this capacitor. So what we're going to do, according to the spec sheet, let's just pop that up there. This has to be coupled to the pin 4, has to be coupled to ground with a capacitor. We're running 5 volts, otherwise you're connecting it to the VCC. So we're gonna connect that to the VCC, and then we're going to change this regulator, which is an AMS 1117 5 volt regulator, to a 3.3 one. Wow, my throat is not good right now. So I'm not going to be doing this the right way because I don't have the tools to do it the right way, so I'm going to brute force it. And I'm going to be doing that by putting a bit of solder on my iron here, then basically just pushing this capacitor off. There we go. Right, I think that is good, that didn't short. Great, now comes the grisly part. I'm going to do the same thing with the 5 volt regulator. And see if we can get the whole thing heated up enough to pop it off. There we go. Alright, didn't break any pads. Now I should be wicking the existing solder off before applying the new regulator, but the last solder wick I had, I left at work, so that's just great. Yeah. So basically I'm going to be pushing this down and soldering one of the pads. And that seems about right. And hoping that it will stick before I burn my fingers. I think that may have done it. Alright. Okay, we're a bit too close here. I'm using a fluorescent bulb in my lamp. I'm going to change that to LED because it flickers when the light gets too intense on the camera. So that's a bit of an issue. Also, it's quite... Okay, that is not stuck down though. That's bad. Alright. Looks about right. Alright. putting a nice big chunk there, because what we're going to do is connect, as I mentioned before, the fourth pin of the IC here, the serial IC, to the output of the regulator. Now this is probably going to be bad because I cut this piece of wire just about exactly the length it needed to be, and that is usually not a good idea to do. Well, not a good thing to do is what I meant to say. Also, we have to be careful that we do not short these two pads, because the second pad over there, that is ground. So we'd be shorting our power supply to the ground basically if we shorted those. I wish I had my tweezers. Alright. If you decide to replicate this, you would probably be wise to, well, do it better soldering practices. Alright. Great. Now, another problem. The 5-volt supply, since it's a 5-volt board, the USB 5-volt does not actually go to the regulator. That is for the VN pin. So, if we connect the 5 volts to it now, it will actually be a 5-volt board, and yeah, that won't work. So we're gonna have to disconnect the 5 volts from the USB from the rest of the board, and then wire directly to the regulator. Now, the good thing is, and which we're going to be removing, unfortunately, is that they've put a diode here, and we're going to be removing that to separate the board from the 5 volts. Unfortunately, that will also remove our safety, meaning that if you plug this into USB and you connect power to VN that is above 5 volts, then you're going to be causing trouble for your USB, because then power is going to be flowing into your USB board. Just beware of that. Now I'm going to be removing the diode with the same brute force method as before, by basically heating the whole thing up, because I'm not going to be using it anymore. Come on, let go. Also, if you're doing it, well, stupid like me, you want to first off be careful not to heat it directly on the board, but heat on the pad, and secondly not apply too much force, because since we're heating the board and the pads as much as we are, they may let go of the board, and then you are in trouble. There we go. Right, now this pad out here is the 5 volts from the USB, and this is well, power of the board basically. So we're going to run this all the way up here to the input pin, no sorry, over here to the input pin of the AMS 1117. Alright, here goes. Again, I cut the wire exactly the length it needs to be, which as I said, is not a good idea. Actually, I think I messed up. Yes, I did, because I've cut it to go here, because I thought, sure, I'll just go on the other side of the diode, but then I realized that it's connected to main power of the board, and that would be a bad idea. See if this all fits. It just might. Alright, let's give that a go. Yes, I know that I should be using third hand or something like that for this, but I really prefer holding the board in my hand. Alright, this is not going to be pretty, but it's going to work, I think. Alright. It's stuck down. So, yeah, it's protruding a bit out towards the pins, as you can see. I'm not sure if the side pins will actually still fit, and I've misplaced the box I had them in before. Oh, there we are. Alright, let's see if the pins will still fit. Yeah, that's a problem, or is it? It fits beautifully. So, still good. Alright, well, let's see if our little modification worked or if we've fried the thing. Let's plug it back in. Starting up and blinking once a second. Works a charm. And just to confirm that I've not left something out, because I've not actually done this before, I've just come up with the idea, so well, many others probably have, but yeah. Alright, let's just go like this. Can we do that? Yes, we can. So, if we check the ground, 3.3, 3.3. Now 5 volts should also be 3.3. It is. Well, all is good then. Yeah. We've converted an Arduino Nano to 3.3 volts. The reason they're running 5 volts, I think, is that the specifications of the Atmega 328, which is this chip here, says that you need 5 volts, or it's 4 point something to run 16 megahertz, which is what Arduinos usually run. But I've always ran this exact chip on 3.3 volts, and I've never had any issues. I think issues may arise if you go to the extreme of the temperature range of this chip, but that's not really inside my well, usual use case. So, oh yeah, I almost forgot. Well, the primary problem of converting the Arduino was that we may have issues with. One moment. That we may have issues programming it, because the Arduino, we know that Mega is 3.3 volt compatible. We're not sure about the serial converter, so let's just send a little sketch where we increase the frequency of the blinking LED. And it's programming, and here we go. Now it should been quite a lot faster, and as you can see, it is. So, all works, all is good. That is all. Thank you for watching. See ya.